Hello and welcome back to 3D Drawing 3D Model Railway. In today's lesson I'm going to talk about what I'm going to do with regards to coupling. Now how you do these is completely up to yourself. Everyone's going to have their own opinions on how they want to couple things together. One option you could be thinking about maybe is using NEM pockets, something like that, or you could potentially use Pico else's if they'll fit. The one thing that you really can't do with this is use 3D printed rigid couplings. And now, personally, I wanted to try and come up with some idea of how to 3D print the couplings and still be able to have the lateral movement so that as you go around tighter corners, it's going to be able to pivot okay. Whereas the issue we've got, if you try and draw the couplings rigid, is they don't pivot as they go around corner, and you end up with just the whole thing just springing off the track. So I spent a bit of time and had a conversation with a bloke called Steve Farmer, who's got a layout at Tanner's Hill. His suggestion was to print a coupling a little bit like a bogie in effect. So you've got a central boss with a pin that holds the normal rapido arm on it, and that would work for the coupling on both ends of the runners and on this end of the main chassis. The other end of the chassis, I'm going to try and see if I can draw potentially something that comes out from the end of the bogie here, so that the whole bogie has the coupling attached to it. That's going to be my plan. Rather than using an actual coupling in between here, I'm going to 3D print a bar that goes between the two, so they're going to be not permanently coupled, but that bar will allow the lateral movement side to side, so they will be able to go around corners okay. I'm going to start drawing on the runner wagon here, so I'm going to select the runner wagon and then spin to the bottom. Okay, so what I'm looking at in here is drawing on the bottom surface. I'm going to draw just a normal circle in the midpoint of the wagon. I'm going to draw it about 4mm in diameter, and distance from the front of the wagon, I'm going to go for 4mm. You can pick whatever you want here yourself. But yeah, I'm going for 4mm. I'm just going to define the side, so that's going to lock in position. And I'm going to extrude this down by probably 3mm. No, it's going to be too high. This is going to take a little bit of testing. I've not actually done this myself. I'm going to do a little bit of testing to try and get the height correct on the coupler. Obviously, it needs to be the same level as all the rest of them. So initially, I'm going to go with a 2.5mm center boss here. I'm going to drill that out. Let's go for 2mm and extrude that back up into the wagon. 2.5mm. Okay, so that's going to act as like our pivot point. Then going to draw off of this base surface the actual coupler pocket itself. So if I do an offset from there, and I'm only going to offset it by say 0.3mm. Okay, and then have another one. It's going to be a little bit bigger. Let's go for 6.5mm. This is going to act as like the pivot point itself. There you go, you've got 2mm there. So that becomes a new body. Okay, so this is attached to the wagon. This bit can then pivot around the pivot point here. May need to make this a little bit bigger gap, may need to make it a little bit smaller. It depends on how this works. but that's where I'm going with that at the moment. The next thing I'm going to do is I'm going to draw the coupling arm coming out. So I'm going to edit that sketch. Okay, so what I'm going to draw next is just a rectangle. I'm going to draw this two-sided, so I'm going to come, actually that needs to be, better way to do this. Let's draw, yeah, do it from that side. No, I'm going to have to draw a line, I think, from that midpoint. I'm going to use it as a construction line. Okay, and then I should be able to draw a rectangle snapping off there. I'm going to draw two. About 4.4 millimeters from this point on the back here. Oops, that was construction that doesn't want to be. Let's change that back to normal. That's it. And we'll draw the same. There. Let's define the width from there to there. 0.9 millimeters, and the same on this side. 0.9 millimeters. Okay, and if we select these two parts, we can then drag that. Actually, that'll work. Drag that 2 millimeters upwards. Let me just check that. That create a new body. They have. So I've got to combine those two. I can't just change them because one appears before the other one. So combine them. Okay, so we've got that point. Okay, so now to spun this round, so I'm looking face on. I'm going to create a sketch on the end of the arm that just created. I'm going to be using a center point rectangle. And find the midpoint down there and the midpoint there. Okay, and I'm going to draw this outwards. Okay, so define the length. I want 6.2 millimeters. Oh, actually, what's that done there? Let's undo that. This needs to be locked into position. That shouldn't have moved. Let's fix that. That's 6.2. And then the height, I want 2.6. So I'm sort of matching the back plate on the back of a rapido here. Can then extrude this forwards. Now, from experience, we've always found that the back plate should be just ever so slightly in front of your buffers. So if I'm coming forwards 1 millimeter, that's going to give me enough support there and also give me the distance that I shouldn't end up with buffer locking. Okay, so that's the back part of my coupling there. So you want to turn that sketch off underneath here. I'm done with that. So little things like that bug me, and I've just got to turn them off so that I can't keep looking at them. Okay, so the next thing I need to draw is the part that comes forwards. Okay, so the next bit is going to be drawn on the front plate's face here. Draw a rectangle, go from corner to corner, 1 millimeter wide, 2.6 high. And I'm going to extrude this out and measure this. 5 millimeters. Okay, good. Okay, so the next bit I want to draw is the bit that comes outside of this part of the coupler. going to draw a line that comes vertically down, define the distance from there, 1.3 millimeters, and then from the midpoint to the corners, like that, and extrude this forwards by 2.5 millimeters. And then on the inside surface here, slice through that. I want just a small thin 1.5 wide by 2.6 high, and extrude that towards us, and it only comes out ever so slightly just to stop the two couplings being able to split apart. So that's that coupling done at this end. The only thing we need to do now is draw the pin or go in the middle. So again, we're going to be using a new body. So this is coupler. Let's rename that. Arm. And we'll create a sketch on this surface again in the middle. Offset that inside one minus 0.2. If it needs to, I can just drill out that little bit extra on the inside there. That's going to extrude upwards. I'm just going to go, where's it gone? Minus 1.8 millimeters. And then draw, that should create a new body. It has, good. And then I can draw on that body. Now, the circle I draw here has to be bigger than this, or as big as this circle here. So, get a circle on that one, and it's going to come, so that's the size, where are we looking here? That's 6 millimeters. And if I turn the rest off, the reason I'm doing that is I don't want it to be able to snap to it as I join it. So I'm going to just extrude this downwards, just 1 millimeter, and then those two should join, but it won't join to anything else. And then I can turn all the rest of these back on. Rename that coupling pin. Okay, so we've got the arm and the pin. This has got a little bit of lateral play, sorry, a little bit of vertical play here. It will also swivel if you wanted to, and obviously I might test this. You could possibly put a couple of pins on this chassis coming straight down, which will stop it from pivoting too much. But I'm going to just try it, see how it is with it like this. If I need to, then I can stab those. In fact, if I draw them on, if they're no good, I can just cut them off if they don't work. So on the chassis here, make sure we're still on the chassis attached to the runner. Yep. Draw a sketch on this flat surface here, and I'm just going to draw some circles for this sort of position. 5 millimeters in diameter maybe. So define the distance from there, 4.5 millimeters, and the distance from the front edge, 9.9 millimeters. If we extrude this down, what that will do is that will stop it from being able to pivot beyond that point. So we'll come down 2.5 millimeters. OK. and then hopefully we should be able to just mirror that across because we've got this center line here. So mirror feature, select that feature, mirror plane. Now we've got to find out which one's the mirror plane that we're after. I think it was. No, I'm not happy with that one. Let's have a look on this. We've got a lot here. That one. So plane 15 within the runner. That's it. Yeah. Okay, so that's the coupling for this end sorted now. Okay, now you could, if you want to copy that across and have it at the other end, then you've got to repeat those both ends. Okay, so I'm going to copy over the pivot and the center boss and these two features here as well to the other end. So we're going to create a mid plane, go between the two ends of the buffer beams here. And we've got that mid plane in the middle there. Okay, so I'll turn the coupling arm off. I need to mirror. If we do these as individual parts, the mirror that we've done there and the original little pin that stops it swiveling, and select the mirror plane to be that middle one. So that's going to copy those two bits over. If we then mirror features, we're going to look for, turn off the coupling pin. So we're looking for the little boss here that we drew. So that and that mirror plane comes across in the middle there. Okay, so we've now got that. You can then use the same coupling arm if you wanted. I'm not going to waste time copying and moving that across. You just print it twice if you wanted to do that there. I need this to be in here as well. So I'm actually thinking about maybe creating this as a pattern across. Do a rectangular pattern. Which was it? That and that in this direction. We can drag this across. Turn that off. No, it's not going to be in the right place. It's not far, not an issue. We could, can't do that as a new body. We could do this as a new body though. Edit, new body. Okay, so these two are separate now. We're going to do move copy, create copy. Okay, it needs to move upwards a little bit. It's probably only 1.2 there. Okay, click on OK. And we can move. Sorry, let me get the right thing here. Close that down. I'm going to combine these back up again. So combine main chassis for the runner with 76 and 77, which are those two centre pins. Oops, don't want them to. Okay, so that's now on there. I need to move this into a crane chassis. Do that. Cut from there, paste it there. Yes, that's the way to do it. Click on OK. Should have gone out of that one, yep. So it's now in this one. So we've now got that same little pocket here. Okay. Now, as I said, I'm going to use a bar to go between the two rather than this coupling. So these are two will be continually coupled. Do I want to do that? I can't make my mind up, if I'm honest. I wonder whether coupling might be better. Yeah, let's just try that. So I copy that coupling arm, and paste it into here. That looks okay there. Okay, hopefully that won't join. Catch up with a lagging. Right, now you can see what we're going to have to do is cut a slot out in the buffer beam here, which is absolutely fine. I've got no issue with doing that. This looks like it's beyond the buffer, which is fine. Okay. What we could do is just so that you can see exactly what we've got here. We do a coupling arm here. Move copy. Okay, a couple of it. Around 180. Okay, you can see that what we're going to have here as an issue here is these are actually going to be too far apart, these two arms, which is why I was thinking of doing a separate could close these up on them. I was thinking of just doing a separate beam to go between the two. Let's just cancel that. I'm going to keep this actually, and what I'm going to do is if I select that face and that inner profile here, no, that's not what I want. Extrude this that direction and tell it to cut. Why isn't it deleted you? That's fine. Select you and you. Extrude. Cut. Actually, let's undo all this lot. Excuse me a minute, getting a bit messy here. Redo that. Okay, so we've got to this point here. Right, let's jump up to crane chassis, which is where this coupling is now, and then we can edit this. offset face either. Right click, extrude. What I'm looking to do is cut that off. And then I can remove that body like that. Okay, good. If I find mid-plane between that face and that face, and then I can extrude this front surface here. To that mid-plane. Then I can just mirror this across and it should theoretically fit around that loop. That's the plan anyhow. Okay, so the next thing I need to do is cut out a hole on here. So if we're still on the crane chassis, select that front surface, let it spin around and slice. Turn that construction plane off. Turn the worm off. There we go. Okay, so I need to cut a hole out here. So I'm going to use center point rectangle and I'm going to project first. Catch up, it's lagging a little bit. Project and will it allow me to? No, it won't. That's a pain. No, it won't let me. That's fine. If I just draw a rectangle that's a little bit bigger, like that. You've got the height here, both top and bottom. And extrude all the way through. We've now got the slot that this coupling can slide in and out of. It doesn't need the little pins either side to stop it rotating. Turn the runner back on, the jib back on. Now, hopefully, we've got separated here. Why are you separate bodies now? Oh, okay. Extrude that. Just gonna have to drag that in to join those two. Okay, if we mirror that body across that plane, will it fit round a little circle here? Yes, it will. And click on OK. Okay, so now we've got like a little rod that goes all the way through. That's our coupling that end, and we've got coupling that end. Okay, so the last coupling we need to think about is one to go on the end of the bogey here. Okay, before I get on to doing that bogey, I'm just going to combine the main body with the centre little boss that we drew here. So they're now one. Okay, so in this one we should have the bogey pivot pin, the bogey, the main chassis, the coupling arm. Why won't that? I wonder if that's not touching. Okay, let's turn the main chassis off. I bet what's happened is the height of this is actually too low and it's not actually touching. Pivot turned off, so let's see what we're looking at. And here we go. So if I select this top surface, extrude, turn the body back on. There you go. It's too low. Okay, now I'm going to be careful how this joins. I want to try and maintain that body one if I can. Just rename it. Okay, so we've now that basically wasn't combining because the height of the centre boss to the floor wasn't matching. Okay, so let's look at sorting out this coupling here. If we put the bow pin back in and look at what room we've got. Okay, I'm going to just draw a circle on here, just to act as my axle. So I'm creating this as a new body, and all it's basically going to be is roughly where the axle is going to be, so that I've got some sort of idea about what space I've got here, which isn't a lot, to be honest. And what I'll need to do is get a coupling. I might be able to come over the top of it. Let's see if I can do that. And from there, I'm going to draw a rectangle from there. .8 millimeters. I might be able to get away with one actually. 4.5 across, 1 millimeter, and then extrude that. Here we go. If we come forward 7 millimeters on there, join. That should join to the bogey. Wondering whether I need to think about whether the wheel would catch on the inside. No, it won't, because it'll pivot. Of course it won't, it'll pivot. Okay, and then if we copy this body actually, that's a nice little cheat way to do this. Let's go back to the runner, select the coupling arm, copy, and that's put it up in this top one here. And bring it up and rotate it 180. Okay, and then I'm going to chop this end off. So I'm going to create a sketch on that surface there. Draw a box of that size, doesn't really matter about it. And select everything within that circle, within that rectangle, sorry, and extrude that to cut it off there. I've now got this arm here. I can move that and just click it there. Back into that extrusion. It only came 7, so I'm going to come 8mm, 8.5mm. Let that jump back forwards. You can see how that's now overlapping. What I'm looking to try and do, that needs to be centered on here. So that's 4.5. Let's move that body. Like that. Extrude that to that. Okay. That coupling now becomes part of the bogey now. And as I said, I was looking for this plate here, the end of the inside of the coupler, to be beyond the buffer there. Okay, and then we can minimise that, minimise that, minimise that, turn the crank body and the pivot on. Okay, so now we've got our couplings all the way across. The only thing that you may need to check is height of the couplings, and that'll obviously I'll have to print it, have a look, see what comes out, and then make any changes if I need to. But I think that's about it with where I'm at with couplings. Gives us a good 3 different ways of having a coupling. One that's just a solid bar, one that we've created like a little bogey pivot, and then one that we've attached to the bogey here. So I hope you've enjoyed watching today's lesson. The next lesson, really, I'm just tidying up the print now, tidying up the CAD, ready to do a print.